Hello everyone. Now let's start. Operating system security. Now let's start with the introduction. Now the first thing, what is the operating system? The operating system, it is just a software like any other software. Okay? Now it runs just above the hardware. Okay? Also it abstracts away all the low level details, okay, regarding the hardware. Now it is providing us, or it provides us with API abstract programming interface to build a higher level applications. Okay, they just give us instead of the whole process or the low level details, we just take the command or the thing which is the API. It is shares, manage and enable access to hardware components such as processors, memory, hard drives, network cards, USB devices, monitors, keyboards, and so on. Now look at this image, okay, and you will see how is the operating system work in theory. Now you see, as you see, many processes here. We have a process 1, 2, etc. to up to process n. Okay, each process has its own program and its own data. Now in this example, we just put one program and its data with one process. Although you can put many programs into one process. Okay. Now look at this again. We have process 1 has a program section and data section. Okay. Now this is, as you see, this rectangle is the operating system with security, scheduling, resource mechanism, memory, disk, network, display. Now if I want, and here is a memory device, this disk device, which is the hardware. Now if this process, for example process 1, want to write into the memory, okay, you can see we have to check first for security, the scheduling, to make sure no overlapping between the processes, and the resource mechanism. For our example here, we want to write into the memory, which is the memory. We will write memory, yes, and this is the memory device. Okay. Now what is the types of operating system? Of course, operating system is very large. There's a large number of operating systems, types and version, and all sort of devices. For example, if we want servers, PCs, laptops, we will use Unix, Linux, or Windows or Mac OS. Okay. For mobile phones or tablet, iOS, Android. For game consoles like Wii, like PlayStation, Xbox, and so on. Networks, device, routers, for routers, switches, firewall. There's Cisco iOS. The I here is I capital, but here for Apple is I small. So Cisco iOS, okay, and John for OS. John OS. Embedded devices or IoT devices, industrial controllers like home thermostat or heart pacemaker. Why operating system security is important? Now, of course, if the operating system is down, the whole thing is down. Why? Because it is the first line defense against any unwanted behavior. It protects one user from another, protects unauthorized processes from overwriting critical section of memory and storage. And this is very important. I will give you assignments. This is very important. I will give you assignments, but remember, this is very critical information and very critical knowledge. So use it precisely, please. I warn you, okay? Now again, it performs identification and performs identification and authentication. We ensure fair sharing of hardware resources. Now the ultimate goal of attacker is to take control of OS, as we say above, because it is very important, because it controls the whole hardware, writing data, credential, your informations, everything will be here. Now OS security is important for OS designers, those one who write OSs, application or apps developers, of course, or programs, end users including system administrators. Now, this is some notable data breach I gathered from the internet that happened the last 5 years. Okay, now we have Equifax, one of the largest credit bureaus. Now, application vulnerability on one of website led to data breach. There was an application in their website that has one vulnerability. Imagine that, one vulnerability that led to data breach, and this is one of the largest credit bureaus, not some small company or like this company. Heartland, it is a payment system. There was an SQL injection vulnerability. Now you can read about SQL injection, but in briefly, SQL injection, we use a database and we inject some variables into the, let's say, some data into the variable, into some variable, okay, that this variable not filtered, so we get error and we get information from that. Okay, this is SQL injection in briefly. Okay, again, read it if you want more information. Uber, it is famous car sharing. Okay, it is the hackers were able to access Uber's GitHub account and found username and password credential to Uber's AWS account. Okay, this developer guy forget to remove his username and password. Okay, and he uploaded to GitHub, and one of the hacker found it just suddenly, okay, or by coincidence, and okay, so he say, okay, no problem, I will hack you. JP Morgan Chase, one of the largest bank in US, hackers were able to gain root privilege on over 90 of the bank's servers. Imagine that. This is one of the largest bank in the US. Okay, the bank also, although the bank spends 250 million on security every year. Imagine that. Now, Sony's PlayStation Network, of course, it is famous, PS4, PS3, and so on. Hackers gained access to unencrypted credit card numbers and passwords. Plus, site was down for a month. Imagine company like Sony, okay, that its site was down for a month. Imagine that. How many lost? Okay. Again, RSA Security, it is a security giant. Hackers stole secure ID authentication tokens. Critical customers, there's a critical customers to the RSA, like Lockheed Martin. Now imagine Lockheed Martin. It is one of the top military companies that sell weapons. Imagine that there's a security in that. That's very dangerous. As you see, for Lockheed Martin might be at risk. Imagine if he is at risk. That's so messed up. Now, VeriSign, which is a digital certificate issuer, when you open google.com, okay, you will see up above a green lock, which is SSL. Now, hackers gained access to the privileged system in that. Imagine that. Adobe hack exposed customer names, IDs, passwords, debit and credit cards information. Verizon Communications users' personal data leaked due to misconfigured security setting on one of cloud servers. Now, all of the above was very critical section, but this thing, Stuxnet, is very, very, very dangerous and very critical attack. Now, Stuxnet, it's a malware that being used in Iran's nuclear plants, but a cyber attack that yield physical result, which is this is a cyber warfare. I think they think, okay, that it is between U.S. Israeli defense system and Iran's. I don't know, in fact, but this is very important and this is very critical thing here. Okay, as you see, I put a line here because this is nothing. The above is nothing compared to this one. Okay. Now, OS security and network security. OS security is something, and network security is something, but they are intertwined. Okay, but that is impossible to separate them. Now, malware come in over the network. Of course, if I want to send the malware to someone, I will use the network. But how I will run or execute this malware? By the OS. Okay, so this is the relationship between OS and network security. Okay, attacks and breaking into system are almost always carried over remotely. Of course, as I mentioned, and OS is turned into zombie or bot that is a part of very large botnet. Of course, botnet is a network. That used so many large number of computers or devices, okay, that can attack any system using DOS attacks. Okay, operating system security environment. Now there is a general requirement of a security OS or a secure OS. How the system achieve its security goals? If its security goals, I will tell you about that in the next slide. But we have two models. We have a threat model and we have a trust model. Look at this image. This image is the threat model. Okay, this is I make my own viruses, malware, attacks to check if the trust model, which is this samurai guy here, is secure and can, let's say, defend itself. Okay. Now this is the security goal. Now in each system you have to check three components: CIA, C, confidentiality, I, integrity, A, availability. Now security or confidentiality guarantees that the release of data to unauthorized people never occurs. So what is confidentiality? Briefly, confidentiality makes sure that the data cannot be read by an authorized person. Okay. But integrity make sure that the data cannot be written or cannot be changed, but we can read it, no problem. An example on that is the hash functions, SHA-1, SHA-512, and so on, MD5, and so on. Availability, make sure that the system is available. Now look at this. The threats we have. This is the threats: malware, physical theft, malicious user insider, and external attacker, which is a hacker. Now OS security controls we have for physical theft, file encryption, memory encryption, code signing. For the malicious user, access control policies, reference monitor, audit trail. For external attacker, we have a firewall, network access control, intrusion detection. Okay, for a malware, we have a sandbox, whitelisting, memory protection, and secure code and libraries for the magics. Types of attacks. We have two types of attacks. We have a passive and we have an active. The passive, stealing information. The active, making a computer program misbehave. Okay, so the defense for passive, by cryptography, shuffling data to make it hard to recover the original data. Okay, of course, cryptography would encrypt the data. The active one, software hardening. Okay, adds a protection to program to make it hard for attacks to make them misbehave. This is the active, and this is the behavior. Now, how operating system load, or what is the OS loading stage? The first thing, the BIOS, basic input output. Support for access to the boot device, HDD, CD, USB, how to access to our network. We put the rules how to access. Now the other stage, bootstrap loader, program that fits and install the next piece of OS. The bootstrap loader, this is this part to load the kernel. Okay, this is a small program that can be found on the hard drive. Okay, on the first section, on the first 512 byte, okay, that load the whole operating system or the whole kernel. primitive kernel. This is the low-level functions of OS. Okay, this is the core of the OS itself. Advanced OS functions like file system, directory structure, device drivers, and so on. Card drivers, sound drivers, network drivers, and so on. Advanced add-on, which is the supportive for GUI, which is the graphical user interface. Why is it is hard to secure the OS? The first thing, the OS, if it is connected to the internet, it is very hard. Why? Because I want to download this file, I want to check this website, it is hard. OSs rely on multiple peripherals, external connected via USB or integrated graphics cards. Now, many drivers, so for example, card driver, which is may run in a privilege mode, okay, and the attacker found that you use this card driver. The card driver, by the way, the card driver is a program, okay. So if this program run in a privilege mode, root access, for example, or administrator, the attacker can use this to his own benefit. OSs are huge and complex, provide a rich environment to applications. So if the operating system is very large, for example, look at this, Windows XP, it's a 50 million line of code. Imagine that. So how you will find this vulnerability in 50 million line of code? It's impossible. Almost impossible, okay? Or hard, very hard, okay? Also, the features are the enemy of security. If I want to add features to this Windows or to this operating system, of course, absolutely it is the enemy of the security. More code, more bugs, and more security errors. Code reuse propagate vulnerability. So for example, there was a well-known vulnerability made its way from Linux to Android. Okay, I think it's Android. I forget, but you can read about it. I forgot to put it, in fact. But there was a very known vulnerability because, as you know, the Android is adapted from Linux. Okay, now look at this image. Global shortage of security professionals. Why this course is very important for you? Because, as you see, this is one of the conferences I attend. Okay, I take this photo. Global shortage of cybersecurity professional by 2019. There is a 2 million shortage around the world. Imagine that. So you may have a chance if you take this course and you focus with me and you keep moving forward, learning up to cybersecurity, okay, there is a chance for you to get a job. Rate of cybersecurity job growth as versus IT job overall, multiplied by 3. Imagine that. Organizations believe half or fewer of applications for open security jobs are qualified, 84%. Imagine that.